Unit 1, Day 3. Fancy name for a bunch of stuff that you've done before, so hopefully you remember it. Graphical analysis. Sounds fancy, but we're going to do 3 or 4 Algebra 1 things, basically. Maybe Algebra 2. Just so you know what's coming, 4 Roman numerals, and basically they get shorter as we go. So the first one's the longest and downhill from there. Roman numeral 1. Zeros, roots, and x-intercepts. Zeros, roots, and x-intercepts. And I guess the good news is those are all the same thing. That's not 3 different things. That's 3 different words for one thing. Let's see. X-intercepts is maybe the most helpful of the words because you can visualize what's going on there. It means the graph is crossing the x-axis. This is sort of how I think through what I need to do to solve these things. If a point is on the x-axis, what do I know about its coordinates? Is there one of the coordinates that I know? Phrase it that way.
0.
Is what's 0? The y-coordinate is 0. Right? That's what makes it sit on the x-axis. So if I want to find one of these things, then I'll set y equal to 0. And that will sort of force it onto the x-axis, and then I'll have my x-intercepts. So set y equal to 0. That's the main thing. After that, it's all kind of follows from there. We'll solve for x, and we'll give our answer as a point. So when you get down to x equals 7, don't stop there. The answer would be 7, 0. Okay, so that's the theory stuff, the concept thing. The how you do it, we'll get some practice here. Or I guess the practice is mostly on the solving for x. So you remember how to solve all these equations. So let's find the zeros of f of x equals x squared minus 5x minus 6. So part of this is just vocabulary. Do you know what we're asking for? Set it equal to 0. The other part is, well, do I know after I set it equal to 0, what do I do next? What's that? Factor it. So multiply to 6 and add to 5. This is always the one that trips students up because 1 and 6 kind of work and 3 and 2 kind of work. But only one of them really works. Which one is it? 6 and 1, because they've got to be different signs to get to negative 6. So if we do a negative 6 and a plus 1, x equals 6, x equals negative 1. Again, we don't want to stop there, though, because that looks like x equals 6. That's a vertical line at 6. We want the point 6, 0, negative 1, 0. Example B. Find the x-intercepts of h of x equals x cubed minus 5x squared over 4. Find the x-intercepts. H of x equals x cubed minus 5x squared over 4. Again, the setup's the same. Zeros, x-intercepts, roots, all mean the same thing. Set it equal to 0, and then solve for x. The reason we have 3 example problems, though, is the solving for x. There's some different things we can do. All right, this one's a fraction. So thinking back to fraction rules, what makes a fraction equal to 0, the top or the bottom? The top. So the 4 doesn't really matter, right? If the top is 0, dividing by 4 is still 0. So I just need to set the top to 0. Another thing you could do, that some people would do, is they'd say, well, let's clear the fraction out. So let's multiply both sides by 4. And on the other side, you'd have 0 times 4, which is 0. So either way, you're only worried about the top being 0. What do you want to do with that? Still factoring, by the way. Yeah.
Take out an x squared.
Take out the x squared. So that's GCF. It's like the easy kind of factoring, but it's the factoring that you don't do all the time, so sometimes you forget to even look for it. But yeah, take out an x squared. And then set each of the factors equal to 0. So x equals 0 and x equals 5. But I don't want my answers like that. The whole point was we want to find the x-intercept. That's where y is 0. So 0, 0, and 5, 0. Let's do one more. Again, all the examples are primarily to work on solving different types of problems, different types of equations. But we'll hit the third vocabulary word here. Find the roots of g of x equals square root of 3x minus 4. So we set it equal to 0, or set y equal to 0. What do you want to do to start to solve that for x? Move 4 over. What next? Good. Square both sides. The right side's easy because the square and the square root just cancel each other out. Do I need to put a plus or minus on that? No, but why am I thinking that? Like, when do you put a plus or minus on there? If you square root both sides. So be careful. There's one in the homework where you square root both sides, so you would need to put the plus or minus on there. So 16/3, comma 0 would be our root, or our x-intercept, or our 0, because they're all the same thing. It's just making sure you know all 3 words. Roman numeral 2. Points of intersection. So let's find the points of intersection of f of x equals 2x squared minus 16. G of x equals x squared plus 5x plus 20. Point of intersection. So think about what graphically a point of intersection might look like. This one might have two. It's a parabola, one steeper than the other. What would the coordinates of that point? I don't know how to ask this question though. Like they have the same x and the same y right there. That's what makes it a point of intersection. So if their y's are equal to each other, then let's set the y's equal to each other. So f of x is a y value, g of x is a y value. So if f and g are equal to each other, then that means 2x squared minus 16 needs to equal x squared plus 5x plus 20. Again, we're just solving. So let's move. It's a quadratic because there's an x squared. That means I won't be able to get x by itself, so I need to move everything to one side and hope that it factors. So subtract the x squared over, subtract the 5x over, subtract the 20 over, and let's see, factors of 36. 9 and 4 would be a great pick. Minus 9 and plus 4. Negative 4 and 9. Values. Side note, I don't remember if this happens on the worksheet or not. I don't think it does. But what if we got to here, this quadratic that would not factor? What would we do then?
Quadratic formula.
Yeah, then we have to sing the quadratic formula to ourselves. Or out loud, whatever. But the quadratic formula if it won't factor. Am I done with this problem? Box these up and walk away? No, because I'm asking, so the answer is probably no. What am I missing? What else do I need to do? I need the y values because it asks for a point of inflection, not an x value of intersection. So how do I find the y values? Just plug them in. Plug it into f or plug it into g? Right, that's the best answer. It doesn't matter because they're supposed to give me the same thing. So pick whichever one you think is easier and plug it into that one. I think f of x looks easier than g of x, so I'll plug them into f. I suppose if you really wanted to check, you could plug negative 4 into both and make sure you got the same thing. Let's see, 16 times 2 is 32. 32 minus 16 is 16. Negative 4 is 16. And again, if you're so inclined, you plug it into G and you get the same thing. F of 9 times 9 squared minus 16. Let's see, 81 times 2 is 162. You guys have your calculators out. Rather than having to, go back to 3rd grade and borrow and old school subtraction. So 9 comma 146. Points of intersection, set them equal to each other, solve from there, make sure you give your answer or answers as a point. Questions on that? That's it for Roman numeral 2. Roman numeral 3. Increasing, decreasing, and constant. Oops. Increasing, decreasing, constant intervals. So those are different things, right? Unlike Roman numeral 1, where there was 3 words that all meant the same thing. Obviously, these 3 things are not the same. And when we say intervals, we mean x intervals. So we don't really care about, well, the y values, I guess, tell us if it's increasing or decreasing, but we report the answer in terms of the x's. let's do from a graph first. Copy that graph down. Tried to make it as simple as can be and yet still include one interval of each type. When you got a graph, you read a graph like you read a book. You read from left to right. I think Japanese might be backwards, but that, whatever. In English, in America, we read left to right in a book and in a graph. So this first interval right here, as I move left to right, is that increasing or decreasing? Decreasing. And so I could list decreasing first, but I think the homework already has the interval types listed out, increasing, decreasing, constant. So I'll do it that way here. So that's decreasing. That's the only tricky one, because if you're not intentionally reading left to right, it's easy to look at that graph and say, oh look, it goes up. You're like, well, yeah, it goes up, but that's reading it backwards. It's going up. As I read it left to right, it's going down. So it decreases from negative infinity up to negative 2. So be careful. Don't let the up arrow fool you. As you read left to right, it's going down. Yes, ma'am. Great question. Parentheses versus brackets. So at negative 2, it's like, well, it decreases, but it's changing at negative 2, so we don't want to include negative 2 on either one. Like on the increasing interval that's coming up next, from negative 2 to 1, it's not increasing at negative 2. It's not decreasing at negative 2. And then same thing for constant from 1 to infinity. I guess I need to color that as well. Not that you really need the color-coded chart for increasing, decreasing, and constant. Again, the only tricky one is when it heads up and to the left. You know, your brain says, oh, it's going up, but not really. You got to read it left to right. All right, now why we need a calculator other than to do 162 minus 16. With calculator, find the minimum of y equals negative x times the square root of 5 minus x. Oh, yeah, without a calculator, I don't. Yeah, you could do this in calculus without a calculator, but we're not there yet. So grab the calculator, go to y equals and put that function in. Let's see what it looks like. Something like that. Do you know, or could you explain why it stops right there? Like, why doesn't it keep going? We sort of discussed it last week in terms of domain.
Oh, because if x went any higher, it'd be negative, and that you can't do that.
Right. If x is bigger than 5, then we're square rooting a negative number, and we can't do that. So that's why the graph stops at 5. So we can't go any further. All right, that was kind of a side note. What we wanted to find was the minimum. And so, like, on the graph, you can, like, visually identify it. Oh, it's right there. It's the bottom of the valley. But how do I know where that is? Well, there's two ways to get there. One way is wrong and one way is right. The wrong way is if you just hit trace and you just kind of eyeball it. Say, well, it looks like it's lowest, like right about there somewhere. You're close. The right way to do it is the button second calc. So it's still the trace button, but you need to do the second button first. Second calc. And if you remember that much, I'm pretty sure you could take it from there. What button do you think would be the best button if we want to find the minimum?
Intersect.
That's right. It's like, well, how about minimum? And then it walks you through what to do. So be careful, you don't just start hitting enter. Left bound, that means get to the left of where the minimum is. Basically, how the calculator finds it, it does a guess and check. So it's asking, like, well, where do you want me to look for this thing? So let's give it a place to look. Left, so get left of the minimum, press enter. Right bound means get to the right of the minimum. So get on the other side somewhere. And you can see there's a couple of little arrows up there. That means the calculator is going to guess in between those two spots. And it asks for a guess. It doesn't really matter what you put for a guess as long as it's between those two. Most of the time you can just press enter and be fine. If you want to be sort of kind to your calculator, you can try to get to the minimum and it'll find it a little bit quicker, but it's like the difference between 1/10 of a second and 2/10 of a second. Yeah. So let me back up. Get completely out of there. So clear, clear, clear. Y equals, we put in the graph, we go to the graph. Second calc, that's the big thing to remember. Second calc. Or second trace. Across the top. Find it. You make it that far, it's like, oh, well, it asked me for a minimum, so I guess we'll do minimum. Left bound means get to the left of the minimum. Right bound means get to the right of the minimum. And then for guess, you can just hit enter again. And the answer then to 3 decimal places, 3.333, comma, negative 4.303 is the minimum. The bottom of the valley, lower than his neighbors, however you want to phrase that. Little side note before we move on to the next interval. So what was the question? Right bound? Once you get to your left bound, you press enter. And then it prompts you for right bound. Get to the right of it, press enter, and then it prompts you for a guess. Got it? Here's a question for you. Does that graph that I just drew have, how many minimums does it have? That's kind of a trick question because you can defend either answer, 1 or 2. I need to be a little bit more specific. They're both, A and B are relative minima. Or local minima. B is the absolute minimum. So some people were holding up 1, others were holding up 2. And again, it kind of depends. And so you're right to be like, that's a trick question. So usually we'll put one of those descriptors on there to be clear about what we're talking about. Absolute minimum means that the lowest point, period. Relative or local just means, well, relative to his neighbors, A is at the bottom of the valley. Relative to his neighbors, B is at the bottom of the valley. So they're both local minimum.
So which minimum would you focus on more, the absolute one or both of them together?
It depends on the question.
Okay.
And this is a bigger deal in calculus, And it'll always tell you which one it's looking for. Or which ones, maybe, because there could be more than one.
What if you have two that are at the same point?
Yeah, that's always the question. So if A and B were like equally low, then you would have two absolute minimum. Yeah. Or if you think about, oh, you guys don't know what the sine curve looks like, I don't imagine, but you could have infinite if they all went to the same. Right, if you had a graph like that and that was neatly drawn, then all of those would be absolute minimums.
Okay.
We're not going to be worried about that. Roman numeral 4 and final. Average rate of change. Average rate of change. I wish we used that. You've done this before. You may not have called it average rate of change. Which I wish we would use it, that term, in the freshman or sophomore or somewhere before you get to me, but oh well. Do you know what it is? Has your teacher used that term? It's slope. It's fancy talk for just slope. So good old y2 minus y1 over x2 minus x1. So you've done it before. You may not have called it average rate of change. And the reason is when you get to calculus, there's a lot of talk about average rate of change versus instantaneous rate of change. We're not worried about instantaneous rate of change, but we are worried about average rate of change. So let's find the AROC. That's how we abbreviate average rate of change sometimes. Versus IROC, instantaneous rate of change. Find AROC for y equals x squared minus 3x from x equals 1 excuse me, to x equals 4. This is just like you did it in algebra. You get a point, and then you use the slope formula to find the slope. So you've done this before. Well, let's do it again. So y of 4, let's plug in 4. 16 minus 12 is 4. Y of 1, let's plug in 1. 1 minus 3 is negative 2. So y2 minus y1, and you might also remember it doesn't matter what order you go in as long as you keep the same order, as long as you don't mix it up. So I'm going to do 4 minus negative 2 over 4 minus 1. The y values over the x values. So that would be 6 over 3 equals 2. So everything we do today is like you've kind of done it before, but now we're putting maybe some new names on it, but maybe not. Some of you look like you'd seen average rate of change before. So today's assignment is worksheet 3. Again, done it all before, but you know, how good is your factoring? If you remember all this stuff. Reminder that due Friday are worksheets 1 through 4. Answers for worksheet 3 are posted already. And we only have like 3 minutes left. Will you please return my battery-filled calculators to the crate over there? For increasing, decreasing, you'll almost always use parentheses. Because if it's changing, then you don't want to include an endpoint. Yeah, I would still use
Wait, what?